first paper, and that's a paper about learning loss and the effect of COVID-19. And that's going to be presented by Melvin Voren from the University of Amsterdam.
All right, thanks everyone for attending this session. My name is Melvin Voren. I'm from the VU University of Amsterdam, and today I'm presenting this work together with my colleagues from Amsterdam, Leo Cornelis and Chris van Klaveren, as well as co-authors from Politecnico di Milano, who are also here in the room today, Melissa Diaz-Lema and Tommaso Agassisti. Welcome, Tommaso.
Thank you.
And today I'm going to talk about exploring international learning loss patterns, machine learning investigation using PISA data before and after COVID-19. So outline, so I will first briefly go into the background of this, then I will describe the data that we will be using, OECD PISA data, and then we will give some preliminary results from this machine learning analysis. So what is nice about using the PISA data at this moment is that we now have the PISA 2022 wave at our disposal, which is the first wave that was collected after the COVID-19 pandemic. And we will be using a machine learning approach to assess the impact of the COVID-19 pandemic because we perceive the pandemic as an exogenous shock to the educational production function. And if we train the model on using data before the pandemic and then use the model on data to predict scores after the pandemic, we basically can estimate the learning loss because the predictive model that we'll be using is actually the educational production function. So we assume that there is a change in the educational production function due to the pandemic because of closures, studying from home, etc. And yeah, these changes are not in the model that has been trained, for instance, on 2018 data, and then using this model to predict the scores in 2022, the unpredicted variance will then capture the change in the educational production function. Oops. And in addition, PISA is a cross-country data set, so it also allows us to estimate and compare the learning loss across countries. So we can see which countries, for instance, have a higher or a lower learning loss. So the inputs to the educational production function, some of them may be affected more. For instance, the home situation. Before COVID, the home situation was maybe important, but maybe after or during COVID, it was way more important because students were spending much more time at home compared to before the pandemic. So yeah, this may also differ across countries. For instance, some countries have longer lockdowns, longer school closures. Other countries may also be like maybe more rural than other countries, so they have maybe more space at home than, for instance, maybe in the Netherlands or in Belgium, where there are more people on 1 square kilometer. And also the socioeconomic status may play a part, because, for instance, if your parents are well educated, they can basically kind of substitute the thing that the part of the education that would otherwise be attained at school, and that would move at home because you're spending more time at home. So what has been found in the literature thus far, if you look at the learning loss, well, for the Netherlands, Maldonado and Christophe de Witte estimate also around 0.20 standard deviation. Others maybe a little bit lower, Engsel, Vrij and Verhaag in 2021. If we look at meta-analysis and systematic reviews, it's around 0.14 of a standard deviation. And a recent paper by Jakubowski, Gajderovic and Patrinos, they actually also use PISA data, but they adapt a linear model, and we actually are more flexible in our approach because we use a more flexible machine learning method to estimate the educational production function. So our sample, we focus on EU15, actually EU15 minus 1, because Luxembourg, tiny little Luxembourg over there is not included, so it's EU15 minus 1, which is around 130,000 students in 2022 in the PISA. And we focus on the common variables, so the common variables that are being collected in all the 14, 15 minus 1 countries. Alright, so the descriptives across cohorts, well, we focus on the 2015, 2018 and 2022 PISA waves. And yeah, what we have in the data set is, of course, the outcome variable PISA math score, the age, gender, migration status, native, second or first generation, age of the arrival for the migration students, socioeconomic status, so this is actually this one, home possession, and on the bottom there are a couple of questions which are like qualitative questions about like feeling an outsider, sense of belonging, making friends. They're also there. So you can see that actually it's like it's pretty comparable across the different waves, the average, the means. So what we do is we train the model on the data before the pandemic, so either 2015 or 2018, and then we predict the scores after the pandemic. So yeah, we evaluate the model's predictive performance over time by comparing the results over different cohorts. And if there is a consistent gap in test scores between, for instance, 2015 and 2022, or 2018 and 2022, this is the COVID-19 learning loss. And there shouldn't be a difference if you do this same thing for 2015 and 2018, because there is no pandemic between both of the waves. Well, I will go quickly through this. There is also some missing data, of course, like around 10% more in 2022, likely not at random. We do some imputation. I will go through this. We actually use this Miss Forrest imputation, machine learning based imputation. So this is the baseline analysis, so these are our preliminary results. So we have to focus first on the diagonal. This is like our starting point, so this, and this. So this is the 2015 model, using the 2015 model to predict the 2015 data. And we see that there is no difference, so these lines, they are on top of each other. That's good. Also for 2018 on 2018, it looks like that. And for 2022, it's also like that. So our model works. Then on the right column, this is where we use either the 2015 or the 2018 data or model to predict the data in 2022. There we see suddenly that there is a shift. You see? The green and the orange lines are not on top of each other. And lastly, the top one in the center, this is not the case for 2015 on 2018, which is also good, because here there is no pandemic. So actually you can use the model trained on 2015 data to predict the test scores in 2018, because there is no change in the educational production function. It only starts to happen after the pandemic. Okay, so in terms of learning loss, what we see, if we use the 2015 model, we find like 19.1 points, or 0.21 of a standard deviation, and for the 2018 on the 2022, 18.5 points, also like roughly the same, 0.20 of a standard deviation. And this is also quite similar to the previous literature estimates. They were like 0.17. However, if you look at the different countries, you see that there is large heterogeneity across countries. So in France and the Netherlands, pretty high, but in Germany and Austria, there is like no learning loss. That's also what's been found in the literature. There's not a lot of studies on Germany, but the studies that are out there on using like German data find like 0.03% of a standard deviation if you use the PISA math scores. So this is maybe more for the future. So what we are now have done, we use the GLM model, but you can see that actually there are some other models. For instance, the XG-boost model. It has a lower root mean squared error, which means that it's a better model than the GLM that we have over here. So you can see over there that we can do that in a later version. Also, this is a robustness analysis for the socioeconomic status. So now the Y variable is not the math scores anymore, but the socioeconomic status. And actually, we don't want to see a difference in the socioeconomic status using this technique. And that's also not what we find. So, they are largely laying on top of each other. Actually, there are some things that we still have to investigate here because the OECD has like a way to compare the different waves in terms of socioeconomic status because of the growth in the economy. So you have like an index for 2015, 2018 and 2022. That's something that we still have to tweak, but that might have some small changes only. So conclusions. So first of all, conclusion, the learning loss can be estimated using machine learning techniques on different PISA cycles, so training, pre and post estimations. And that we estimate this overall learning loss due to COVID-19 at around 0.20 of standard deviation, which is comparable to what has been found in earlier meta-analyses. And again, there is a large heterogeneity across EU 15 countries, for example, Germany and Austria, virtually no learning loss, versus France and the Netherlands with a very large learning loss. So the next steps, things that we might do, will do in the future is adding a time trend to the model, rescaling the socioeconomic status across different cycles using the PISA definition, further heterogeneity analyses, and subsamples of students using propensity score matching. So we are basically still working on the model to make it work better. But the first results are quite hopeful. Okay, room for questions.